In this video, we're going to talk about how to factor polynomials completely. And we're going to go through a couple strategies, including going into grouping, which hasn't been done in a video yet. All right, so when we do grouping, here's some descriptive words to describe what's happening. But in simple terms, what we're doing, and I think it's best to be done using an example. One reason we use grouping typically is when we have 4 terms, and what we're going to do is we're going to pair up 2 terms together because they're going to share a common factor, which will later be factored out. So let's look through the first one here. So the first thing we're going to do is group the first 2 terms together with parentheses like you see done here. Then we're going to do the same for the second, and we're going to keep the sign in between these as shown. All right, so now when we look at the group, we're just going to focus on factoring this group using greatest common factor. And we notice that both of these terms in this parenthesis would have an x squared in common. So we will factor out an x squared. When we do that, what's left over is x plus 3. Now this is important. Once you do the first group, this parenthesis of the remainder after we factor out is going to be duplicated over here. So we're going to write x plus 3. If you take the last term in the group and divide it by the factor term, you'll get the common factor that needs to pull out, including the sign that it needs to be, because that would be a very common mistake. Now that we have 2 parenthesis terms that are the same, we're going to technically combine them into one factor. And then the factors outside are going to form their own parenthesis. At this point, there's nothing more we can do to factor this. So this would be your final factor. Okay. If we look at example 2, which is written down here, we're going to do a similar technique here. The only difference is we're going to switch x and y because as it shows, x squared plus y can't be factored. Right? So we're going to rewrite this where x is partnered up with x squared, and then xy is going to be partnered up with y. And so we'll group these together, and it'll look like this. Now, in the first group, we're going to take out 1x. Now, this is a very, very common mistake with students is when we factor out the x, right, they'll leave an x, and they'll forget to write the plus 1 here. All right, now the same type of situation occurs over here. We're going to factor out the y, and then we're going to have a plus 1 remaining. Now, we have 2 common parentheses, which we should. That's the one hint for you. And then the 2 terms outside, the 2 factors outside, are going to combine into a common, into a parentheses. And then we have our answer there. Okay, so that's grouping. So we want to make sure we can group them together. We want to factor out what's in common. The GCFs become a parenthesis, and then the other parenthesis just kind of stays the same. All right. So now if they ask us to factor completely, what this means is there's several strategies that you can use, and we want to keep factoring it until it can no longer be factored. So there's 4 types of ways, and these are the 4 ways that were discussed in class. We have factor out the greatest common factor. In this case here, we would take out 3 and x, and then what's remaining is x plus 2. In the second type of way we did, these were perfect squares, or where we're factoring when a equals to 1. Right? So if a equals 1, we take the factors of c, that would add up to equal to b. In this case, this would be the perfect square where we square root the first and the last and combine it. Another way is if we end up having a is greater than 1, and we would use our 5-step method. And then last would be with the grouping that we just shared. Now, how do you know to use grouping, for example? Typically, there's 4 terms. How do you know to use greatest common factor? There's usually 2 terms. Sometimes we'll use this with 3 terms as well if a is greater than 1. We might see some examples like that. All right, so let's take a look at 2 examples here. All right, now the first is a trinomial. So we have 3 terms here, and we want to look at I think first it helps to kind of look at the variable terms. So we have x cubed, x squared, and x. So the greatest common variable they have is just x. So from each of these terms, we'll remove an x and then change the power down by 1. Then if we look here, I like to look at the smallest number, the smallest number, and then factor it. So in this case, the factors of 3 are just 1 and 3. And we see that we can take out 3 from each of the other terms. So what's going to happen is that 3 and x become the factor we take out. Next, we must look at the parenthesis and see, can we factor 6 so that it equals to a positive 2, right? And we can't. So at this point, the factor is done completely. So the only thing we can do in this case was GCF. If this were some other number that could be factored, we would continue factoring it until we are done. All right, next. We're going to look at this binomial. 7x to the fourth minus 28x squared. So my first step would be to take the x squared from both terms and factor that out. And then we notice that both terms could factor out 7 because I'm going to factor 7 first, and the only factors are 7 and 1. Now, this time when we look in the parentheses, this can be factored. This is the special case where we're going to square root the first and square root the last. And we would end up with this as our answer down here. Okay, so and at this point, this is as far as we can go for factoring this particular problem. Right, last we're going to talk about how to solve these things. Now, if you know how to factor, the only difference is we're going to set each factor equal to 0. So when we're solving an equation, there's going to now be an equal sign, where if you look at all the previous problems, there was no equal sign involved. Now, what we're going to use is this zero product property. So everything is going to be on one side, and it's going to be set equal to 0. So in this case, we're not equal to 0. So to do so, we must move 10x to the other side. Right? So now we have this equation equal to 0. So now we have to go through our 4 ways. What way can we factor this right now? And we could do where we multiply 2 times negative 10 and do our 5-step process, or we could factor, actually we can't do that because we have an x here and an x cubed. So that method won't work just yet, actually. So we need to pull out the common factor, which would be x from each term and 2 from each term. And so now we have 2x as our common factor, and then our x squared plus 4x minus 5. So now at this point, the 2x is going to be set equal to 0, and we'll get x equals 0, and then we're going to factor this, and you'll see that we get x plus 5, x minus 1. So this will be equal to 0, this will be equal to 0, and then this will be equal to 0. So what ends up happening is we would divide the 2x, we would divide by 2, 0 divided by 2 is 0. In this factor term right here, we would subtract 5 from both sides and get negative 5. And in this factor term, we would add 1. And so this particular problem has 3 factors: 0, negative 5, and 1. Sorry, solution: 0, negative 5, and 1. And what this means is this is where the graph crosses the the x-axis. These are called the x-intercepts and the roots. So they're called the roots, the solutions, and the x-intercepts.